Yes, ma'am.
Okay, thank you. Method of separation of variables for solving PDE. Okay, so here we will solve partial differential equations uh, with only two dependent variable and we will solve only heat equation, wave equations, and Laplace equations of two dimensions. Suppose our okay, x and t, two dependent variable. The method is we will find the solution, uh, and you have told me that you have done this, you have solved the heat equation or wave equation. So do you know the method?
Yes, ma'am.
So you already know the method. Okay, then it's very simple for me. Okay, okay. So basically what we will do, so I am not going on elaborate then explanation. Okay, so I will try to find out the solution uh, in such a way such that we can express the solution in this form, that is one is only dependent on x and one is only dependent on t. So this equation will transform to, will be x. Okay, I am just writing, this is double derivative, x dt. Okay, so I can write this in this form, that is x. Okay, the left hand side is this 1 by c square. X. So since this is only in terms of t and this is only in terms of x, so they can be equal only if they are equal to some constant, say lambda. Okay, so we will have our equation as is lambda c squared t is equal to 0, and one will be x dash minus lambda x is equal to 0. Now you know how to solve this type of differential equations. So you will have, depending on this lambda, that is whether it is greater than 0 or less than 0, your solutions will be like, suppose this lambda is equal to 0, so you know the solution of this will be lambda is 0, so this will be x c1x plus c2, and your t will be c33 plus c4. Suppose your is lambda is positive, say p square, so your x will be c1 e to the power px plus c2 e to the power px, minus px, okay. So that will be, t will be c3 e to the power cpt plus c4 minus cpt. Oh, CPT, sin CPT, cos CPT. Okay, so depending on the boundary conditions, we will get the solution. So we will solve this type of partial differential equations with the help of this method, and we will have our boundary conditions, initial conditions, so that we can find out this C1, C2, C3, C4, or whichever is applicable. Suppose suppose our heat equation is given by del U del T is equal to K del 2U del x square U x0 is equal to phi x belongs to 0 t greater than 0. So you have to solve this heat equation, that is, it is given, and your conditions may be Dirichlet, that is U0T 0. It may be Newman, that is UX 0T UL, that is T, sorry, this should be. This is L, this capital L, that is the your limit. Whatever in your x is given in 0 to L, this is capital L. Okay, so this is Newman conditions, and so depending on these boundary conditions, we will solve this equation. Okay, so our solution we will take in this form. Okay, this is only a function of x, this is only a function of t. So this equation we can write is as, that is, x t dash is equal to k x double dash t, which will imply I can write this as t dash by t. I mean, I will write this k here, this will be x, and suppose I am writing this as minus lambda. This is my choice, you can write it even plus or anything. I am taking just minus lambda. So the first equation will be t dash plus lambda kt. T dash plus lambda kt is equal to 0, x double dash plus lambda x is equal to 0. So we will solve this, and suppose my first equation, what will be the solution of this? T is equal to a constant e to the power minus lambda kt. Achha. For this, there will be three condition, lambda 0, lambda greater than 0, lambda less than 0. Lambda 0, that is the same as before, that is, suppose my x is alpha, alpha beta, and so for this your solution u will be alpha x plus beta multiplied with this. Okay, our solution will be in this form. Achha, for what will be when it will be greater than 0? Remember your lambda, your, what will be this? Tell me, when your lambda greater than 0, what will be the solution, this x, solving this equation? That is m square is equal to minus lambda. Okay,
C1 e to the
so
power root lambda x.
yes.
C1 e to the power root lambda x plus C2 to the power minus root lambda x.
Okay, and when I will have this is minus lambda, so your m is equal to I lambda, so there will be cos and sine, alpha cos root over lambda x plus, and another will be e to the power in terms of, and we will write it in form of cos hyperbolic. You remember e to the power x plus e to the power minus x by 2 is cos hyperbolic. So okay, this is lambda less than 0, that means this square root is valid, lambda less than 0. Okay, so I will have the solution for u will be this multiplied with this, and for this multiplied with this. Now depending on the next conditions, that is, we have solved this, and which solution will satisfy our boundary condition, that will decide which form will be applicable. Okay, so for we will and when x satisfies the boundary conditions, this problem, okay, probably you have, I will directly solve this. Okay, that means your u0 t will depend on if you just satisfy this x. Suppose I am considering the Dirichlet boundary condition. Dirichlet boundary conditions, that is u0t is equal to u lt is equal to 0 for all t greater than is equal to 0. So we will, from these and satisfying these conditions, and uh, since it is valid for t greater than 0, so all t, so basically this will means if I x0 is equal to xl is equal to 0 with the condition satisfies with the solution, that will be equivalent to all t. So now my first solution is x is alpha x plus b. Okay, Now x0 is equal to 0, x0 is equal to 0 implies beta is equal to 0. And probably you will be able to do this type of I what I mean to say, do I need to do this calculation elaborately, or you will be able to solve this easily? XL is equal to 0 implies this beta is already 0, so your alpha capital L is equal to 0, so it implies alpha is equal to 0. So this solution will be a trivial solution. We are looking for non-trivial solution. Lambda less than 0. The solution was this, okay? X is equal to lambda cos hyperbolic x plus beta sine hyperbolic x. So x0 is equal to 0 implies alpha cos hyperbolic that is 0, that term will be multiplied 0, and you know if sine hyperbolic 0 is 0, so this term is always vanish. So but you know this is not 0, cos hyperbolic 0 is not 0, so it implies alpha is equal to 0. Okay, you just have to put the value and you have, and xl is equal to 0. Since alpha is already 0, so I will put beta sine hyperbolic this is equal to 0. Since this term is not 0, it will implies beta is equal to 0. So this is trivial. Now lambda greater than 0. So that was alpha cos root lambda x plus beta sine root lambda x. This is x. So x0 is equal to 0 implies alpha cos root lambda 0. This is you know this is 0 plus beta it is all 0, so it implies alpha is 0. Now xl is equal to 0 implies alpha cos. I want to write this down since alpha is 0. And if your beta is 0, so your both alpha and beta is 0, so it will be trivial. So for non-trivial solution, beta shouldn't be 0. So sine root lambda L is 0, and you know this is sine n pi. So I would write my lambda in, if I am considering this L, so your lambda n will be oh, I am sorry. First, okay, lambda is equal to lambda n. I have to, then it will be n pi L square. N greater than is equal to 1. So, my solution will be xnx will be, this is beta is non-zero, beta sine this beta sine root lambda is your n pi by L. So this will be n pi x by L. And so your t was uh, your t was c e to the power minus lambda kt. So when it will be in terms of this n pi l, so I can write this t as is equal to some cn e to the power minus k lambda is n pi by l whole square t. Okay, so I am just erasing this. I need to write here. That's why. So your u nxt will be this xnx tnt. So this will be. I am multiplying these two and writing this as bn sine n pi x by l e to the power minus k n pi by l square t. Okay, so if we know these coefficients bn, this is but before that we have to superimpose for all these n, and we will get the solution in terms. And okay, first let me ask you, up to this it is okay with you? It's okay with you up to this calculation? It's okay, right? Okay. Yes, tell me. Where this lambda greater than 0? Okay. Your alpha is 0. Fine. So if you took your beta 0, then the solution is you won't get any solution. This is also a trivial solution. But the other two cases, there was no other option rather than alpha and beta is equal to 0. So we have to take, since we have two options, two multiplications. So I am not taking as 0 for non-trivial solution, and I will take this as 0. Otherwise, your all the solution will be trivial. That's why I am not taking beta is equal to 0. Okay, so your okay, I have found out all the un. So now your unxt, so superposition of all the n, I will have this bn sin n pi x. Okay, to the power minus k n pi t, and we will take this all n is equal to 1 to infinity. Now if we found this bn, then our solution is known, and now we have another. We have used these Dirichlet boundary conditions for solving the heat equation, and there was another condition ux0. That means ux0 is equal to phi x, means at t is equal to 0, some condition is given in terms of x, so you have those conditions also. So now we will apply this, that is your ux0 is equal to bn sine n pi x by l, because you are putting t is equal to 0, so that term won't occur. This is given by phi x. And if you remember, this is a sine series, and for Fourier series we can have our coefficients in the form of this bn, so we will get the, okay, but before that, how it comes, suppose you don't remember this, so 0 to L, suppose phi x sine, I am taking any m, not m pi x by L. So this will be 0 to L. For phi x, I am replacing this. I'm sorry, I have to retain this sine m pi x L dx. So L bn sine, and I will use a property here. Probably you remember or not, I don't know. Sine n pi x by L sine L to 0. You can in fact you can calculate the integration n, or it is L by 2, n is equal to m. So I will use this value, okay, in this form. I will use this value. I have to put here, okay, so bn sine, I have to put L by 2 here, okay. So that will be I have to put L by 2 here, L by 2, that means your this will be bn L by 2, bn L by 2. Means I am taking n is equal to m here, so your m, this n will be same. So if I take this is bm L by 2, bm L by 2, that means your bm will be 2 by L, okay. So your is equal to 2 by L 0 to L phi x sine n by x by L dx. And for your problem, this form of pi x, since I have taken n is equal to m here, so that will be your n also. That will be your n also. 2 by L 0 to L pi x sine n by x by L dx. So for a given problem, your phi x will be given. So you will be find out your n corresponding your descent. So then you will put this bn in the solution and you will get your result. This is integration is done only if you remember this form, so you don't have to do these steps. So you will find out your bn in this way. Your phi x will be given for a given problem, then you will substitute this bn here, all are known, so you have got your u, that is your solution. This was Dirichlet condition, right? Next is, okay, suppose I am doing a problem like del u del t is equal to del 2 u del x del 2 u del x square. Okay, where this is 0 less than x less than pi. So your L is pi t greater than 0, u 0 t u pi t is equal to 0, t greater than is equal to 0, u x 0 is equal to phi x is equal to x, and when 0 less than x or less than x less than is equal to pi by 2, and this is pi minus x. And do you remember the Fourier series form? That is the finding the bn is the same, that will be the coefficient of a series. Okay, now, okay, so for the given problem, your k, that is your k is 1, okay, your L is pi. So I will have the solution in this form. L will be pi, so LL will be pi will be cancelled. So this will be only n square. This is 1. Okay. So the solution uxt is summation. But remember, suppose you have a problem like this, you cannot write down the solution in first steps. Okay, so you need to calculate at least some basic steps so that you have found out this solution, it is known. And this is bn, your k sine n pi, that is sine nx, and e to the power minus k is 1. This is n square t. So this is your solution where this bn is given by 2 by L. Here is L is pi. So this will be 2 by pi 0 to pi, and your phi x is given by x pi minus x. So I have to write down 2 integration, that will be 0 to pi by 2, that will be pi x. Your form was phi x sine n pi x by L. Okay, so this will be phi x is x sine nx dx, and phi by 2 pi, this is pi minus x sine nx dx. Okay, so now you have to integrate and you have to use the by parts. Okay, so then you will get your bn. And please do the integration and tell me what is the result of these two integrations. That means you have your bn is equal to okay, first integrate this. This is 0 to pi by 2. Okay, 0 to pi by 2. Please do the integration and tell me the result. Okay, first you integrate and before putting the, tell me what you have got. Then we will take the limit. This will be x into integration of sine nx. That means x into minus cos nx by n. Then minus plus cos nx integration will be sine nx. Then it will be
Ma'am, 4 by pi into 1 by n square into sine n pi by 2.
acha 4 by
Yes, ma'am.
uh, 1 is sine n pi by 2, and what is the coefficient of sine n pi by 2?
1 by n square. 1 by
1.
n square into sine n pi by 2 into 4 by pi.
Okay, that means the 1
4
pi,
by
4
pi.
by 4 by pi n square into sine n pi by 2, right?
Yes, ma'am.
Okay. And you know, this will vanish when your n is that will vanish at pi. That means 1, you will only have the odd terms, right? This term, only the odd terms we will have. The even terms will vanish for sine n pi by 2. So I will write this in form So I can write this in for all uxt is 4 by pi n square sine n pi by 2. So I can write this 4 by pi summation at n square. N square means that will be if we, but there will be a alternate plus and minus. Okay, so this will be, I can write 2 2n minus 1, or I may write n, it a k is equal to 1 to infinity 2k minus 1 square. This is sine 2k minus 1 sine nx, sine nx e to the power minus n square. N square is 2k minus 1 square t, and there will be plus and minus. First term will be plus, so this will be minus 1 to the power n plus 1. So this is your solution. Okay. Since your sine n by 2 is 0 when n is 2k, is minus 1 to the power k plus 1, n is 2k minus 1. Because first when n is 1, this will be pi by 2 1, and the next will be minus, so you have to take this. Okay, so for k is equal to 1, you will have a plus, and then minus, then plus. So I will write this. So this is your solution of the given equation. Now Newman boundary condition. I think you will be able to do this type of problems very easily. Just okay. So for this, we have to solve this equation with the boundary condition. This is equal to 0, and x dash l is equal to 0. Okay. So we have found out the um, solution lambda 0, lambda greater than 0, lambda less than 0. Lambda 0 was alpha x plus b. Okay, so if this was your alpha x, so x dash x which is alpha, and it says that x dash 0 is equal to 0, x dash l is equal to 0. Now x dash 0 is equal to 0 means your alpha is 0, and your x dash l is 0 is means your alpha is 0, but there is no restrictions on beta. So your this function may be a constant function, that is we may write this, if I write this at lambda 0 is x0 x, it is suppose this is 1 multiplied with any constant of this, so there may be a solution of this form, and your t will be what, okay, your t was যখন lambda was 0, your solution was what was the t? T was c e to the power minus lambda kt. So when your t is 0, so this will is a constant function. So this solution uxt may be a simple, suppose this is a constant function, okay, so that will be included in our general solution. We will remember that for lambda is equal to 0, there is a solution in this form c0. Okay, now when your lambda greater than 0, when your lambda greater than 0, we have the equation in form of lambda greater than 0. Oh, this is and lambda less than 0. Okay, tell me when you put your lambda greater than 0 and your condition is x dash 0 is equal to 0 and x dash l is equal to 0, what do you get? Your general solution was alpha cos root lambda x plus beta sine root lambda x. So your x dash is nothing but minus alpha root lambda. আমি যদি এটা 0, this is 0, so this is beta is 0. L, your beta is 0, so minus okay, we won't take alpha is 0, so and we know our alpha is greater than your lambda is greater than 0, so doesn't matter, it won't be 0, so this term won't vanish, so this should vanish. So this sine root lambda L is equal to sine n pi. So your lambda n is n pi by L whole square. So I have got this lambda and beta is 0, so I will have only this term. Beta is 0, so our solution is alpha cos n pi x by L, and TNT is Cn e to the power minus k n pi by L square t or n greater than is equal to 1. So your unxt is Pn e to the power minus k in pi L square t into cos n pi x by L. Okay, if last time we have taken n is equal to 1 to infinity, suppose I put n is equal to 0, so you know this term uh, n is 0, that means this term won't exist. If n is 0, so you know the cos 0 will be 1, so this will be only a constant, and we have checked that for 0 there may be a solution like this, which is term in form of only a constant. So I will take my limit as greater than n is equal to 0 to infinity, or I may write is as n greater than is equal to 0, and all value containing starting from 0 to n, any, that is, you may say 0 to infinity here. Okay, so I am taking all the value, that means I am taking n is equal to 0, the constant term also. And we know how to find out the bn. Our bn is 2 by L 0 to L phi x cos n pi x by L dx, and when your n is 0, that will be nothing but 2 by L 0 to L phi x dx, n greater than is equal to 0. Okay, so you will be, for a given problem, your phi x will be given, and you will be able to do this integration. You will find this bn, and then you will put in the general form, and you will get the solution. Okay, so now I'm checking whether okay, you solve this equation. Solve ut is equal to 4u xx u x0 is equal to x square 1 and u0 t is equal to 0. Okay, you just put this in this form where you have to find this bn. Okay, check this. This is Dirichlet condition. Okay, so for the previous where we have solved this, this is your Dirichlet solution, right? This. So you can put this. Oh no, this is your for a particular problem. So this is your, where is this general solution? This is your general solution for Dirichlet conditions. You can use this directly and then find out this Bn with the given function and then tell me what you have got. Okay, here this L will be small l. Okay, I am writing here, this will be small l and e to the power minus, that was e to the power minus k. Uh, so your k is 4 here. So this will be 4 and k n pi, this will be small n pi l square, this will be t. Okay, and your Pn will be 2 by L 0 to L 0 to L and I, this is 0, this condition is 0, x less than 1, t greater than 0, this is 0 less than x less than is equal to 1. If this is, I think there is a printing mistakes in the page. If this is L, then this should be also L, or otherwise it should be 1. Your limit if for x is 0, 1, so this should be either, this should be 1 or this should be L. Okay, so take this as 1, this will be 1. So your L will be 1, okay, fine. That means this is nothing but n is equal to 1 to infinity Bn sine n pi x e to the power minus 4 n square pi square t. Okay, and your Bn is, this will be then 2 by 1. 2 by 1, this will be 0 to 1, and this your function is x square 1 minus x sine n pi x dx. So you have to integrate and you have to find out this value. Have you done this integration? You will find the coefficient in this form. So tell me, are you having any problem with this method or something like that, or it is okay with you? Are you solving the problem or not? Okay, so I will send you some examples for solving heat equations, and next class we will do the wave equation and the Laplace equation. Okay, so let's end it
ম্যাম
here.
বলছি যে 4 বাই যেটা পাই স্কোয়ার এন স্কোয়ার লিখেছেন ওটা আমার পাই কিউব এন কিউব এসছে, তো ওটা না আমি
Basically,
কোথাও
you
ভুল
know,
করেছি?
this problem is given in exercise, and the solution they have the answer in this form. So, but what I think pi cube n cube is okay. So your phi x is x square 1 minus x, right? Okay, so your maybe I don't know. Maybe the answer is wrong. Maybe, but okay. So if you one thing, this is x square and I am doing an integration, so that term should be in terms of cube. So n cube pi cube is uh, okay. Let me check. Oh, I am sorry. This is given is n cube pi cube. The other terms is same.
ইয়েস ম্যাম।
Okay. So I think you will be able to solve this type of heat equations with the given initial conditions and boundary conditions. And okay, the wave equation and the Laplace equation will be same, that is the process will be same, and depending on the conditions you will get your result. So next class I think we'll be able to finish that both wave and Laplace equations. Okay, and I will send you some examples to solve these heat equations. So you will do, and you have told me that you have already solved this type of problems. Okay, so this is very known to you, so no problem with that. Okay, so let's end here today. Or should I continue with the wave equation or Laplace equation right now? Yes, tell me. Okay, let's finish it for today. Next class, that is on, this is 14th, right? So that will be on 21st. That will be the last class. Okay.